involved quite for 20 years now in research on spray application, pest and disease control in grapes and other crops, and have had the privilege really of working with the quantum mist through all of its evolutions over the last really 15 years. Work as an independent researcher now, but have carried on this involvement in setting up and optimising sprayers, and have just recently done some tests on the QM380, the latest head out of croplands, looking at how it performs in grapes relative to the old heads and how it performs relative to other machines. So the purpose of this DVD is to give you, the operator, some indication of how to set this machine up for your canopy. And there's a lot you can do to optimise the performance of any grape sprayer. Getting it right means that you're going to land at least 30% more chemical on the target, and it's worth taking a little bit of effort to do that. There's a huge amount of flexibility that you have with the quantum mist machines in terms of how you set them up, how far the heads are from the canopy, how fast you run the fans, the angles relative to the canopy, what output volumes you put out of each of the heads. And what we want to do with this is give you an indication of the starting point to get the best out of your sprayer in your canopy. These quantum mist fans are the fifth in a series that represent an evolution, I guess, of the straight throughput axial fans used in fruit crop spraying. Started, as I said, about 15 years ago with some air conditioning ducting fans, and what we have now is some aeronautic engineering designed to get the best performance out of a fan. This has come out of the Saudi tech team in Australia, looking at getting the maximum amount of air moved, appropriate sort of air moved for the minimum amount of horsepower to do it. And there's a real point of difference of the quantum mist fans from any of the other sprayers on the market, in that an axial fan moving air directly from the back of a, sucking from the back of a sprayer, straight throughput, direct to the canopy without trying to change the angles, is an incredibly efficient way to move air rather than trying to force air at pressure through tubes and round corners and out to the canopy, as most of the other grape sprayers try and do. So what you're looking at here with a 380mm diameter fan is something which will move about 8,000 cubic meters of air per hour per fan for the energy cost of about 3 horsepower. So you're looking at 14 to 16,000 cubic meters of air moved per hour to each side of the foliage wall. Compare that with something like a holder crossflow type head. You're looking at about 10,000 cubic meters of air per hour moved maximum per head. You need this large volume of turbulent, well-mixed air to get good coverage in grape canopies, and this type of machine certainly can achieve that. What's important with this is that you get the placement of the heads relative to the canopy appropriate to maximise the deposition of spray and to minimise the amount that actually misses the target or oversprays parts of the target, and that's what we want to show you now. When you're setting up the sprayer for the first time, one of the best things you can do is drive around the vineyard, park the sprayer in down the row in each of the different types of canopy that you've got, and have a look at how the heads are positioned relative to the canopy. There's a few really important tricks here. This sprayer here is set up pretty much on the right hand side as it just came out of the yard. That would be a brilliant setup for a big Aussie sprawl canopy, big wide canopy growth, where you're trying to come in at all angles on a large three-dimensional canopy. It doesn't work very well in a New Zealand situation. On this side, the sprayer is set up far closer to what we'd be looking for in the more two-dimensional vertical VSP canopy types that we grow in New Zealand. What you're looking to do really is to get the bottom head to target the bunch zone where most of the money is, or where the money is. And typically what we're recommending as industry best practice these days is 60% of your spray output by volume out of the bottom part of the sprayer, or the bottom head in this case, to that bunch zone area. And 40% of your sprayer output out of the top head to that upper canopy. So this one's actually having to treat a larger height of canopy, and this one here we're trying to actually maximise our penetration into the bunches and deposit on bunches. And that 60-40 split is working very well on a whole range of New Zealand vineyards. So chances are when the sprayer comes from the dealer, it'll have a mix of nozzles in it. You've really got to look to put the appropriate nozzles in to get the output volumes you want out of the two different heads. Just thinking about nozzling on sprayers, one of the real advantages of the quantum mist heads is you've got a large number of nozzles to treat the canopy with. On the QM500 you're looking at 8 nozzles per head. On this QM380 version you're looking at 6 nozzles per head, so 12 nozzles per canopy wall side total. A little bit more expensive in terms of nozzle outlay to start off with, but it's a huge advantage in terms of droplet size. A larger number of nozzles gives you much finer droplets, much better control of coverage in the canopy. And the nice thing about this unit here is, and we've run it quite successfully, you can run with fine droplets into the bunch zone out of fine droplet nozzles, and if you've got drift as an issue you can actually set up the top head with large droplet air induction nozzles, manage the potential overspray out of the top of the canopy and not compromise the critical bunch deposits. So there's a real nice thing going on here with the numbers of nozzles and how you can play with them. The sprayer, typically as it will come from the factory, is set up with high quality hollow cone ceramic TX nozzles. The nozzle sizes we're looking in here, smaller than the TX10 or the black, is giving us a very good droplet size range. Nozzles can be angled relative to the head. You've just got to watch that they don't get snagged on a cane and get pulled out of the airstream. Apart from that, generally we tend to run them just so that they're spraying well into the airstream, and the only time you really need to worry about nozzle placement and trying to pull the nozzles in as tightly as possible is if you're running very low fan speeds to treat bunch line sprays only, to really try and wet the bunch line in a narrow band of bunch line. Otherwise, just running the nozzles just a little bit out from the fan, all of those droplets will be picked up with the air that's coming out of the fan very nicely. So what you've got to think about when you're setting the sprayer up is to break the canopy into the upper foliage wall and the lower bunch zone. So looking at the upper foliage wall to start off with, position the head so that it's more or less in the center of that upper foliage wall, usually just slightly above it and pointing down 5 to 10 degrees. That helps to prevent spray escaping out the top and being lost as drift, and it gives a nice interaction with the air coming out of the bottom fan. For the bottom fan you're doing pretty much the same thing. But you're usually spraying a much narrower band of canopy unless you're in a Silvos or Scott Henry type canopy. So what we tend to do there is bring the head a little bit closer and point it up a little bit in a slightly steeper angle than we use in the top. So we've found that you can run the heads pretty much vertical or with a 5 to 10 degree downwards angle or 5 to 10 degree upwards angle. So a critical thing to avoid with setting up any sprayer in grapes is to avoid leaving a gap in the output between the different heads, and this applies equally to quantum mist units. So by putting a slight downwards angle and a slight upwards angle onto the different heads, you can be assured of an interaction of the spray at the canopy, leaving no gap in the middle as the sprayer rocks down the row or as it moves sideways relative to the row as somebody's not driving straight. So that avoidance of striping is pretty easy to do here and is a critical part of getting this right. So the whole process of adjusting the heads is pretty quick and pretty easy. We've just come around to the outside left-hand side of the sprayer, and what I'm going to do now is just go through the adjustments that I'd run. This is just as the machine came out of the factory, out of the yard, and I'm just going to spend about 5 minutes getting the heads more or less right so that before we run them to test them. Just loosen everything up so that it's, I feel like a chef, loosen everything up so that the heads adjust fairly easily but stay where they're positioned. And what we're looking to do is to get the heads at right angles to the canopy along the direction of travel. What we've found is if you forwards or back angle them, as we do with a lot of other sprayers, because the air is coming out of the fans as a diverging plume, part of that tends to get pushed along the face of the canopy either in the forwards or backwards direction. We've found that consistently the quantum mist fans have given the best result when they've run parallel to the canopy, parallel to the direction of travel. So we'll set that first, and then we're looking at the canopy. We're looking at, here's the upper foliage wall. We actually need to drop this head until it's more or less centered on the wall. So we're just working on the top head. What we've done is we've lowered it until it's just above the center of that foliage wall that we're trying to treat. And I've put a downwards angle on the fan. It's quite useful to have a little angle meter to measure this so that you can repeat it, but you can do this visually quite easily. So that's about right. We need to look at the distance of the head from the canopy. So with a tape measure, the rule of thumb here is that if you're more than about half a metre, you really want to be more than about half a metre from the centre of the canopy. This is running at about, measured from the centre of the fan to the centre of the canopy, this is running at about 650 millimetres. And that's about right. We can run it anywhere between about half a metre and 850 millimetres. If you get further out, you're going to be able to spread to cover a wider foliage wall, but you're starting to lose a bit of punch from the sprayer. So in that region, half a metre from the centre of the row, centre of the canopy, measured to the face of the fan, through to about 850 millimetres. That's a good operating range. The units are pretty robust across that for coverage. As in, they're quite forgiving, they'll give a good result right across that range. Looking to do pretty much the same with the bottom. So we're looking at the bunch zone, get this thing so that it's angled directly at the canopy, slightly upwards angle, and think about where the output from the bottom nozzle is going to go. So we want to be spraying some of that output just below the canopy to allow for a bit of movement of the sprayer so that we don't miss anything out. And want to think about where the top's going. Right now it's going to be spraying into here, so we could probably even pull it down a bit further. So we've got the option of reducing the angle on the fan or dropping the head and pushing it up into the canopy. This sort of setup as it's configured would be pretty much spot on. So pretty easy adjustments. You need a 19mm and a 24mm spanner. Tape measure is very useful. An angle meter if you can get hold of one. A lot of this is done by eye, and it's really important once you think you've got the thing set up, either have somebody standing a distance away and advising you that everything looks okay, or step back a few meters, stand and have a look and think about it. So I'll do that now. And having just stood back from here, what seemed quite appropriate when I was close up to it, this top nozzle, the top output from the sprayer here is actually potentially going to be missing the top of that canopy. We certainly don't want that. I'm going to fix that by just pushing the heads out a little bit further, out to our 850 mils out from the canopy. So I'll just pull the pin on the boom and slide the heads further out. There, it's in the next hole. So now we've taken that out to about 850 from the canopy. Okay, a couple of points worth making. Each of the heads has an independent tap on it so that you can turn off the top head during the early part of the season, still operate the air out of the fan to try and contain drift and to help drive that spray into the lower canopy, but just run with the bottom head. In terms of application volumes, because you've got so many nozzles to work with here, you've got the full range of volumes that you might ever need in grapes available to you. Anything from as little as 100 litres a hectare up to well over 1,000 if that's what you need to achieve. So lots of nozzles, very flexible in terms of application volumes. Critical adjustments that you've got on this machine is how fast you choose to operate the fans. What you'll find with the QM380 is you need to run, they're a smaller head, they move less air than the larger ones. You need to get used to the idea of running them at quite significantly higher fan speeds than the QM500s. What we've found with this is for foliage sprays, you really need to be looking at about 2,500 RPM on the fans to really start to get the fans to perform in terms of mixing the spray and getting good deposits. So that's for full foliage type sprays. You're looking at something certainly no less than 2,200 RPM, but getting up around 2,500 and potentially even higher if you're finding that you need it. That's not the case for earlier season spray applications. So if you just want to target bunches at flowering, work out of Australia has suggested that we actually need to use the minimum amount of air to give reliable carry of the spray to the target. You're also tending to spray a smaller canopy then, so what we usually do is move the heads a bit closer, so we're getting into that sort of 500 mil or even possibly slightly closer to the canopy to try and maximise the amount of spray plume that's directed at the bunches. And we've found that you'll need to turn the fan speeds down to get to not blow the spray past and through that. And we're looking at anything from about 1,000 to 2,000 RPM. And it's really up to you to decide what you need on the basis of how you see the sprayer performing, because there's so many variables involved here. the density of the canopy, how fast you're travelling, how fast the wind is, and how far you've put the heads away from the canopy. But just consider that you need to run at slower speeds for flowering sprays. Possibly look to bring the heads in close and slow them down for bunch line sprays later in the season. But for that full foliage type spray application, you're looking at about 2,500 RPM out of the QM380 heads. Okay, so we've just moved around to the side of the sprayer so that you can see how the heads on that overrow part are positioned relative to the heads behind. And you'll see that the heads on this overrow part of the sprayer are leading the heads that are positioned behind the tank. That's quite deliberate. What we found when we were testing an earlier version of the quantum mist fans was if we directly oppose these large air output volume fans, it was very, very easy to blow the spray directly out of the canopy. So having the interaction of the spray at the canopy, you could literally pump the spray laden air into the air above it. And we would sometimes see it up to 7 meters into the air above the canopy, which is the last thing that we want. So what we did to correct that was brought the heads slightly offset from each other, so that the air is interacting at the leading and trailing edge of the two sets of fans. And we seem to get very, very good turbulent mixing of that spray plume within the canopy, and getting very good deposits. The interesting thing here is that when we've tested these heads just in a single row, as if you're actually running a 3-row sprayer and the two outside sets of heads on each side just spraying into a half row, we've found that you still get very good mixing and coverage just from the interaction between the two vertical fans. So you're not totally reliant on that mixing between the two sets of fans facing the canopy. You can get very good results with both single row and two full row setups. It's probably just worth talking a little bit about spray application volumes required for different canopies. There's a real need to move away from the concept of spraying litres per hectare when we've got canopies on different row spacings, different wall heights, different densities. Wine growers, New Zealand wine growers, are trying to come out with some best practice guidelines for setting spray application volumes on the basis of the amount of canopy that you've got. There's no doubt that this machine can deliver to those specs, and you'll find that the croplands controller will come with a litre per 100 metre calibration option rather than the traditional litres per hectare. So you can switch between the two as you see fit. So they're kind of future-proof for where the industry is going in terms of application volume recommendation. So how fast can you go with these things? We've tested them. Most people are comfortable driving a tractor down a row like this at 7 to 9 kilometres an hour, and we've tested coverage over that range of speeds and have been totally happy with the results that we've got at that. I've seen sprayers being operated in grapes at speeds up to 12 k's, if you're trying to get in before the weather closes in on you or whatever. And we have seen these machines operated at those sorts of speeds with apparently very good results. So quite happy with range of speeds. You might need to look to turn the air up as you speed up to get that canopy penetration. Yeah, the last thing to look at in setting the sprayer up is to really park it in the end of the row. Check that the heads are all appropriately pointing at the canopy, that they're all doing the same thing, that you've not got some heads which are wildly out of line with the rest. You'll find that the quantum mist is pretty forgiving in terms of its head placement. We can get good reliable performance out of it across quite a range of settings, but you want to get it as precise as you possibly can, and this looks pretty good. And then the next thing to do is to actually see the machine running and stand at the row end, watch the machine going, watch the spray going, and the side that I always look to is the upwind side. And what I'm looking for is to see the performance of the spray plume on the upwind side of the sprayer. Is it reliably reaching the canopy? Is it pushing through the canopy into the wind in any gaps in the canopy? And it's quite smart in this case to turn off the outside heads so that you're spraying from the inside into the wind, and see how it's performing in that when it's pushing through into the wind. And what you're looking for is the spray to puff through in the gaps. So every time the spray reaches a gap, you want to see the plume puff through. You want to see it go about a metre beyond the canopy into the wind. If you're doing that, then you've pretty much got it optimised for the canopy you're treating. Sprayer's travelling at about 7 kilometres an hour here. The wind is blowing at about 10 to 12 kilometres an hour coming towards me. So you're looking at the performance of the sprayer on the upwind side of the row, and it's doing pretty much what we want it to do. You can see the spray pushing through in the gaps, reliably getting into that coverage in that canopy. I'll let you watch it.